Hi, my name is Konika Schallen, and I'm a practicing physician in Jacksonville, Florida, with two aesthetic and laser clinics. And I also serve as medical director and senior vice president of clinical operations at Candela Medical. So, for dermatologists who haven't yet read the paper, I want to share how excited we are about this data because this data really shows what the 1940 non-ablative fractional laser can do beyond what we are used to seeing, beyond the cosmetic resurfacing or pigmentation treatments that we typically think of it to be used for. What we found in this study is that treatment with the 1940 non-ablative fractional laser impacted the epigenetics of the skin. And what that means is that it was able to change the way our DNA behaves. Epigenetics is, of course, the science of understanding how external factors impact our genetics. The genes are not changed, but our genes are regulated based on some of these external impacts. And what we found in this study is that the 1940 non-ablative fractional laser serves as an epigenetic impact to do things in the skin that are important to the skin, like reverse aging, improve skin health, and of course, improve on a molecular level, giving us proof of how it works to improve the cosmetic appearance. Well, in practical terms, it means that we actually have a tool now that can help us do something that we previously might have felt helpless about. We know that there are epigenetic impacts on the skin that are negative. We know that UV radiation is negative. We know that smoking is something that's negative. Those are the kinds of things that can contribute to our skin looking aged or our skin cells turning into skin cancers. But now what we can do is use the 1940 non-ablative fractional laser as a positive epigenetic impact by doing treatments that actually can improve the way that our skin actually behaves long term, how it ages, and even the health of the skin and how keratinocytes are regulated so that we have a decreased risk of skin cancers or keratinocyte related skin cancers. We think that this data is really interesting because what it shows us is that the treatment isn't just masking the signs of aging. It's actually resetting the biological programming that drives aging at the cellular level. We took a look at 3.8 million CPG sites in every single sample, and those samples were run at baseline. They were run at every time point of the study, which was after the first treatment, and then all the follow-up time points, which were 1 month post-treatment, 3 months post-treatment, and 6 months post-treatment. And we took a look at sides of the face that weren't treated and sides that were treated. And looking at all of those samples, every single time we took a look at those sites that were associated with cell aging or cell senescence. Of all of the sites that were associated with aging, 83.9%, so nearly 84% of those sites actually shifted in the opposite direction of aging, which means that our cells were reprogrammed not only to just stop aging, but to actually reverse aging. And that's very exciting. So, what we also found that was important is that these changes were durable. So, as I said, we measured at various time points in the study, and we found the biggest change 1 month after all the treatments were completed. But those changes continued to last out to the 6 month follow up period. And we're excited that we're doing some additional work to see if they last even longer. And that will be in subsequent work that we're doing.